Our last discussion of ray diagrams involves concave or diverging lenses. In a diverging lens, we have two focal points. We'll use both of those to determine the position of the image. So here's an object that is placed outside the focal point, and the first ray is drawn parallel to the principal axis, and it refracts as if it were moving away from this focal point. The second ray that we draw goes towards the focal point and then refracts parallel to the principal axis. The third ray that we draw goes right through the center of the lens and isn't refracted at all. If we extend those three rays backwards, what we find is that they all meet at a particular point. That point will show where the top of our image is. Notice that in this case, the image is upright, it is smaller, and it is virtual. And this is the case for all images that are produced by concave or diverging lenses. And again, this is the type of lens that you would use if you were nearsighted. All right, a little bit thin in the middle and thicker on the edges. And here's an example of a nearsighted eye. You see that the normal lens causes the image to be focused in front of the retina. And this causes the image to be blurred when it reaches the retina. What we do is we put a diverging lens in front of the normal lens. What the diverging lens does is it spreads out the light just a little bit, and that way, instead of meeting in front of the retina, the light now meets right at the retina where it should, and you get a nice clear image. The equations that we use for lenses are exactly the same as the equations we use for mirrors. All right, we just have to be careful with the sign notation, and that is that di is positive, that is di for the image is positive if the image is real. Di is negative if the image is virtual. And of course, in the case of diverging lenses, all of the images are virtual. Now for the converging lens, sometimes they were positive and sometimes they were negative. For the focal points, the focal point is positive for a converging lens. It is negative for a diverging lens.